Lab guy here. Here's the adapter from part 1 with the opamp chip on it. As you can see, it fits into a standard vector board quite easily. It just pops in like that. And you solder it from the back and connect it back there, which you'll see later. That's how easy it is to use. Besides the 14 pins, you also have to connect the ground plane of this board to the ground plane of the board it's mounted to. It's very easy. I use solder wick. It makes a very low impedance ground. It's very easy and quick to do. You'll see that later. The amplifier uses two LH0101 high power op amps. Those are the parts in the heat sinks. I use two of 4 op amps in the smaller package as input buffers. Here I'm just seeing where I might place the parts. I'm still figuring out the placement. I flipped over the power op amp so that you can see the 8 pins on the bottom. Though it looks like a TO3 power transistor, it's not. I'm not going to try to drill 8 individual holes for those pins in my vector board. Instead, I'm going to drill out a large hole that allows those pins to poke through. I've marked off the board in a grid so that I know where to drill the starter holes for the 2 op amps. I can use the grid to help place the various components. I drill progressively larger holes as I go, and in a moment I will be switching to a step bit. I'll shut up for a while now and let you watch over my shoulder. It's okay. One more. One more. Now that I have the holes drilled, I use my X-Acto knife to cut the ground plane away from around the edges so that the pins don't touch it and short out. I do this for both holes, of course. This way. Do they fit? They fit. All of the op amps are now mounted to the board. Quick check with the meter to see if any of the pins are shorting to ground.